Hello class, so for today I'm going to provide a solution for activity 3, question number 3. It was what was the air resistance force? So that question had a diver going 15 meters up, 57 kilograms, dropping into the water, and they gave you the velocity of the diver right before they hit the water. So if we look at that problem with our given, we have a person who is diving down into water, 15 meters, 57.0 kilograms. Okay, and when they hit that water, they have a velocity of 14 meters a second. So V equals 14.0 meters a second. Now in the problem, they ask for the force of friction. So they tell you that there is a force applied to this person as they are going into the water or approaching the water, and that their velocity right before it is 14 meters a second. That means that they are slowed down, that their velocity should be greater than 14 meters a second. So we have to find the velocity that they should have had, and the difference, or the loss, is the energy lost due to friction. And that's how we find the force. So number one, what was the velocity supposed to be? Okay, so again, what was it supposed to be? And with all of these problems in this unit, we're always using energy. Eventually we may come back to a force formula, but we need to start with energy formulas. So energy initial equals energy final, so conservation of our energy. Now the initial has an energy of the gravitational plus an energy of the kinetic equals the energy final of the potential plus the energy final of the kinetic. Now you know the initial is 0 for the kinetic. You know the final for the potential is 0 because they're at rest at start and they hit the water, meaning they have no more height to gain. So in this problem, EG initial equals EK final, as we've seen before. Now, that means that mass times gravity times height equals mass times velocity squared over 2. We drop the ends, we rearrange for V. V equals the square root of 2GH, which equals the square root of 2 times 9.8 times 15.0, which equals 17.1 meters a second. So now we know that that person, when they hit the water, should have been going 17.1 meters a second, not 14, which means there's a 3.1 meter a second difference. That's the loss. So we're in our second part here. Number 2, what was the energy lost? So, delta V, the change in velocity for this problem, was 17.1 minus 14.0. This equals 3.10 meters a second. Which, if we have a change, means we have a loss in kinetic energy. So we go back to EK. EK equals mv squared over 2. The mass is 57. The velocity is 3.1. 57.0 times 3.10 squared, all over 2. This gives us an answer of 273 joules. Now remember, any energy that we're dealing with is always in joules, never in newtons, never in meters a second. The unit we use for energy is joules. So our third and final step now we know the energy loss. Number 3, what was the force? As the question asks, it asks, well, what's the force of air resistance? So we know that work is equal to force times displacement. We also know work is equal to energy. So the energy lost in the kinetics was 273 joules. That's the total energy loss due to the force of air resistance. So work equals EK lost. EK lost equals force air times delta D. Force air equals EK lost all over delta D. Force of the air is going to be EK lost divided by delta D, which means that we have 273 joules divided by 15.0 meters, which equals 18.2 newtons. Now, technically speaking, significant figures, this should be 18 because we're dealing with 15 meters. For the purpose of keeping this quick though, that's how you're dealing with this problem. I will be releasing another video shortly about looking at the friction lost or energy lost in springs on the trampoline. All right, thank you very much.